So that is how you do that first part. But before I have this square here, I need to multiply this whole thing by UT. So I'm going to times by my uncertainty of temperature, which is this cell. Now this cell I need to put the dollar sign in front of both the B1 and the B2. The reason why I'm doing that is because I need to keep that cell constant, because when I drag everything through, I don't want it to change. I want it to stay there at that value. So now that I have everything inputted here, I'm going to add my next set. And I actually can just copy and paste this because they're pretty similar. Excuse me. So now I have minus t, which I have here. Then I have ln, the same thing, squared. The only difference here is that instead of my y of t, right here I have my y initial. So I'm just going to change this to 25. And then it still times the same ut and everything. So then I have that there. Then I'm just going to add another plus, and I'm going to paste everything again. And then I'm going to go to my next one. And now this one I'm going to have to do a lot of editing to. So I'm still having minus temperature times parentheses, another parentheses, my temperature itself at the given time minus y infinity, which is 97, divided by 25 minus 97, my initial minus the final, minus 1 divided by the initial minus the final, which is 25 minus 97. Close that parentheses. Then I close the parentheses here. That one I just added was for this whole thing to be in parentheses. Then I'm multiplying by the initial minus final again. And then I go back down here, and it's the y of t, and I already have y of t. So that's it. So the last thing I'm going to do is close my square root parentheses. And then it's going to give me the divided by 0 part, because this is the initial temperature that I had. And then what you can do now is actually, when you have a column of values next to the column you want to calculate, if you double click this, it will automatically move that formula all the way through to the bottom of everything. Now number, this means that the number is undefined, and divided by 0 is mean that you're trying to divide something by 0. So we can just ignore those values. And then if you look right here, you can see all the uncertainty values that we have. And again, you can see how high this is. This is telling me that these are probably the good points to pick. So maybe I shouldn't pick at this. Maybe I should pick my initial to be here, my initial response time to be here. Now again, remember that this is me just making up data, so it could be that my data has been pretty bad. So as you can see, it goes through, the numbers get consistently smaller, and then you get to the final state, and it doesn't like you because in this equation, when you're at the final state, it makes everything 0, because 7 minus 7 is 0 divided by 0 gives you 1, so then ln of 1 is infinity or undefined, so then it gives you this error of number. So that's what's going on there. Now the next thing I'm going to do is, like in the MathCAD, I'm going to set my maximum value, and I want to get max of, so I'm going to use the max function here, and then I'm just going to select my whole range here. And then you just hit enter, and it'll tell you the maximum. Now, since I'm selecting maximum divided by 0, it doesn't like me, so I'll start it at 38 instead, and then see what we get. And it's telling me number, so then I'm going to start at end at 67. And then it'll give me the maximum. Now, I can also do the average as well. You guys should know how to do this in Excel. This is pretty straightforward and simple. So C, it was 38 to C 67, and then it gives me the average value for that range. Now the reason why the average is so high is because of these high uncertainty values. So this is how you can use Excel to find the uncertainties. Now you just plug in the uncertainty equation that you find for the systematic equation and put it in here, and then you put all your uncertainties up here that you have found, and then you can report them as each individual point, but it's probably going to be better, since you're only calculating one tau, to report either the maximum or the average. Maximum is probably better because, again, it does give you a wider range of values that you can look at, but average is okay as well. Now keep that in mind that that your values shouldn't be that high. 365 uncertainty for this thermocouple of for the tau is absurd. So, like I said, it's most likely due to the data that I made up. Now, keep in mind, I made this data up myself. So, again, you're going to have to chop your graphs, otherwise you will get what I'm getting here, for sure, if you don't chop it. And you're also supposed to be getting, in your ln gamma graph, you're only supposed to be getting one slope. So keep that in mind. So, this is how you use Excel to create uncertainty values, and that is all.